Sure, our cosmic neighborhood seems peaceful. No imminent explosions, giant space vacuum cleaners, or weekend wrecking threats. But don't be fooled by the calm. The vast darkness holds terrifying things that would make you hug your pet and pray for a normal solar system when you peek out again. Today, we'll explore some of the most fearsome cosmic monsters we've encountered. Fear of lightning pales in comparison to space currents. While lightning strikes on Earth with their 30,000 amps can be deadly, causing an estimated 24,000 deaths annually, and powerful enough to vaporize metal, they seem insignificant compared to a recent discovery. Researchers at the University of Toronto identified a colossal electrical current in space, a staggering 1,018 amps, equivalent to a trillion lightning strikes combined. This mind-boggling current originates from a supermassive black hole at the heart of a galaxy named 3C303. The immense magnetic fields produced by the black hole interact and churn, acting like a gigantic dynamo, generating this phenomenal electrical surge. Even if we manage to dodge lightning's fury, the cosmos holds other fiery dangers. Every galaxy contains stars hurtling through space at such immense speeds that they break free from gravity's grasp, becoming runaway stars. Stars more likely to mingle than you think. Contrary to their glamorous image, stars are often social creatures. In our galaxy, roughly half exist in binary systems, performing a graceful cosmic dance. Our Sun, however, is a bachelor, gravitationally bound to solitude. Now, imagine these binary pairs waltzing near a galaxy's central black hole, a common resident. The immense gravity can tear them apart, flinging one star off at an incredible 10,000 kilometers per second. The other, like a moth to a flame, gets devoured by the black hole. These rogue stars pose a danger if they veer close to our solar system. Their scorching heat and immense gravity could wreak havoc, disrupting orbits and potentially jeopardizing life. Thankfully, the odds of this happening are extremely low. So, next time you see a bright light in the night sky, don't ditch your homework just yet. It's more likely to be a plane or a particularly reflective pigeon than a harbinger of doom. Galactic Rendezvous. Milky Way versus Andromeda. Heads up for a future astronomical event. Our Milky Way galaxy is destined to collide with the Andromeda galaxy in roughly 3 billion years. Mark your calendars lightly, folks. During this grand cosmic ballet, the supermassive black holes at the hearts of each galaxy will either merge into an even more monstrous one or become a binary black hole system, similar to the stellar partnerships we discussed earlier. The colossal pressure surrounding these supermassive black holes birthing quasars or quasi-stellar radio sources. Due to their name, quasars mimic stars by emitting various electromagnetic radiation, including radio waves and visible light. However, their brilliance dwarfs our Milky Way. It would take 100 Milky Ways to rival a single quasar. The huge large quasar group, yes, astronomical naming conventions can be interesting, is a testament to the universe's grand scale. This colossal chain of 73 quasars stretches a staggering 4 billion light-years across, making it the second largest known structure. The undisputed champion, however, is the Hercules Corona Borealis Great Wall. This behemoth is not a single wall, but a collection of 14 gamma rays burst walls, incredibly bright phenomena triggered by dying stars. Both these cosmic giants are wonders to behold, but with proper eye protection, of course. Stellar endings and the marvel of neutron stars. Massive stars meet dramatic ends. When a star explodes in a supernova, its core implodes under its own gravity, transforming into a neutron star. These incredibly dense objects, roughly 11 kilometers wide, can hold twice the mass of our Sun. How can so much mass fit in such a compact space? Unlike your overstuffed carry-on exploding at security, a relatable struggle, the answer lies in a fundamental force called neutron degeneracy pressure. When neutrons are crammed together at extreme densities, they resist further compression, preventing the star's collapse into a black hole. This pushback is a powerful force that emerges only at such incredible densities. Imagine a small matchbox overflowing with neutron star material. Here on Earth, that tiny amount would weigh a staggering 13 million tons. Some neutron stars evolve into even more extreme objects, magnetars. These cosmic powerhouses generate the most powerful magnetic fields in the universe, capable of warping the very fabric of space-time around them. While a visit to a magnetar wouldn't be recommended, credit cards would be toast. Studying these marvels helps us understand the universe's most extreme environments. Stellar departures from stars to nebulae. Stars are far from tidy celestial bodies. They emit a vast array of electromagnetic radiation throughout their lives, and in their final acts, they often leave behind enormous clouds of dust called nebulae. These nebulae are incredibly sparse, far exceeding the vacuum levels achievable on Earth. However, from vast distances, they become magnificent cosmic sculptures, remnants of departed stars. Over time, we might even imagine these nebulae receiving complaints from neighboring solar systems for their messy stellar demises. Nebulae can stretch for hundreds of light years, and unlike the fluffy clouds of Earth's atmosphere, they assume fantastical shapes, resembling monstrous figures in the cosmos. A prime example lies just 7,000 light-years away within the Eagle Nebula, the pillars of creation. These towering columns of dust are the birthplaces of future stars. Their simple hydrogen gas will eventually ignite, fusing into the complex elements that form planets like Earth. Space isn't all quiet, unveiling zombie and vampire stars. The cosmos may appear serene, but hidden within its depths lurk stellar oddities. Let's explore two fascinating phenomena: zombie stars and vampire stars. Imagine a binary star system where one star becomes a white dwarf, a dense remnant of a sun-like star, primarily composed of carbon and oxygen. Normally, white dwarfs lack the mass to reignite fusion. However, in a binary system, the white dwarf can act like a cosmic leech, siphoning material from its companion star. The stolen mass can push the white dwarf towards a critical threshold, triggering a thermonuclear explosion known as a Type Ia supernova. Aptly nicknamed zombie stars, these undead stellar corpses rise from their apparent demise to erupt in a final, spectacular display. Another captivating phenomenon involves vampire stars, also known as blue stragglers. In star clusters, stars are born together from the same nebula and should have similar ages. Yet, astronomers have observed some stars that appear much hotter and younger than their neighbors. The prevailing theory suggests these vampire stars steal hydrogen-rich fuel from their companions, fueling their fusion reactions and mimicking a youthful state. This vampiric act rejuvenates the vampire while draining the life force of its partner. These stellar oddities highlight the dynamic nature of the cosmos. Far from being static, stars can interact with each other in surprising ways, leading to dramatic transformations and challenging our assumptions about stellar evolution. A galactic booze cloud? Unveiling the Ethyl-Formate cloud in Sagittarius B2. Interstellar travel might involve monotonous stretches of darkness, but a recent discovery in the Milky Way might raise some eyebrows. Metaphorically, of course, in the vacuum of space. Sagittarius B2, a dust cloud roughly 150 light-years wide, contains surprisingly large quantities of ethyl-formate. This organic molecule is associated with the distinctive aroma of raspberries and rum. The presence of ethyl-formate in Sagittarius B2 is intriguing to astrochemists. It suggests the existence of complex organic molecules within interstellar space. This discovery adds to our understanding of the building blocks of life potentially scattered throughout the galaxy. While the sheer volume of ethyl alcohol in Sagittarius B2 is vast, it's important to clarify that it wouldn't be suitable for human consumption. The alcohol exists in a gaseous state within the harsh environment of interstellar space, far from the liquid form we're familiar with. The discovery of ethyl-formate in Sagittarius B2 highlights the unexpected diversity of molecules found in space. It serves as a reminder that the universe holds many secrets waiting to be unveiled by scientific exploration. And if you like this video, click the next one shown on the screen. I'm sure you'll like it. Thanks for watching.